Alright, so hope you are able to understand the part on Kirchhoff first and second law, and this is the answer for the example that I gave you. I1 is 3 I2 is 4.5 ampere, and I3 is 1.5 ampere. Okay, so after you solve that, now we move on to the next example. Alright, so this one becomes slightly more complicated because we have more resistors here, but that's the same thing as long as we are careful enough. So first of all, let's try to use the Kirchhoff first law to find the equation. So let's look at this junction B here. So junction B, we have I3 flowing in. I1 is from B all the way to A, all the way to F until E. So that's the I1. And I2 is from B to C to D to E because there's no other junction. So that all belongs to I2. And I3 is this one. Okay, so you have to identify this very clearly first. So therefore, our I3 will be equals to I1 plus I2. Okay, so I3 equals to I1 plus I2. Okay, so now we're going to use Kirchhoff's second law to form another two equations, because we have three unknowns here, I1 and I2 and I3. So we need three equations to solve it. Okay, so we are going to pick two loops. So first of all, let me release this first. Okay, so first one, we're going to use the FEB, so this loop, and the equation, the direction that we're going to choose is this one. Okay, you can choose yours, but I will use this one here. Okay, so when I choose this, then I start to write for the EMF on the left hand side. So we have two batteries there, don't forget, be careful. So we have two batteries here. So first of all, I'm going to write for E2. So E2, if I look at it, it's actually following the direction of my assumption is coming out from the positive. So I have a positive 4 volt. Okay, and when I go to the E1, is coming out from the negative, therefore I have a negative 2 volt. Okay, the volt no need to write so it's plus 4 minus 2. Okay, let me erase that. Never mind. Okay, so on the right hand side, we have all the potential difference. So we have three resistors here. If you look at it very carefully, we have three resistors, this one, and this one, R1, R5 and R2. Okay, so first of all, let's look at the R5. So R5, we have I3 passing through it, and I3 is the same as our direction of the assumption. So we have positive I3 times R5. Okay, positive I3 times R5, and then we move on to the R2. R2 is the I1. Okay, so R2 is I1, and it's the same as our direction of assumption. So we have I1, R2. Then the next one, we have the R1 down here. So that is also I1, which is also following our direction. So we have I1, R1. Okay, so you can sub values into that. I just teach you how to do this. Okay, so next one, we're going to look at the other side of this circuit, which is the BCDEB. Okay, direction that I'm going to choose is like this. Okay, so I'm going to choose this direction. Okay, but it'll be easier because if you look at those current of I2 and I3, my direction actually follow this currents, so it will be easier later. We don't have so many negative signs. Okay, so first of all, on the left hand side, we have the PD, we have the EMF of E3 and also E2. So E2, okay, E3 and E2. We start with E2. E2 now it also follow the direction, so it's 4 volt. Okay, it's coming out from the positive also. Okay, when it comes to E3, so like the case of E1 just now, the assumed direction has it coming out from the negative, so we minus 4 volt. Okay, that's how we apply the negative here. And the rest of it is the PD, so we have the I3 also positive, R5, and then we move on to I2, R3, and we plus another I2, R4. Okay, so make sure you have all the resistance and their PDs there. Okay, so you should be able to form 3 equations now, and then you can solve to find the current. Okay, so this is the answer there. When you see negative, means that the current is actually opposite to what we have found. The I2 actually is supposed to be flowing in the opposite direction. Okay. Alright, let's do one more here. This one I'm going to go a bit faster. So Kirchhoff first law, I have this as the junction. So I have I1 plus I2 equals to I3. So I1, I2 going in, I2 coming out. Okay, PD, I mean the Kirchhoff second law, we'll choose this direction for this loop. Therefore, we have the 12 volt positive because it comes out from the positive of that. I use the red color. So positive 12, and then there's no other battery in the direction. So we have the PD of I1 passing through the 10 ohm, and then we have the I3. So these two all following is the same as our assumed direction, so we can just write the positive value. Okay, so on the other side, let's say in this case I choose the other way. Okay, just to show you how is that different. Okay, so our assumed direction has it coming out from the negative terminal, so we have the negative 10. Okay, and then it will flow past the 5 ohm opposite to what is given in the circuit. So we have negative I2 times 5, and then for I3 also our assumed direction is also opposite to that, so we have I3 and 20. So at the end you have a lot of negative here if you choose the one that is opposed all the current there. Okay, so but anyway, if you form the other one, it's just cancelling all the negative out. Yeah, so that's why it's all the same. So we have 3 equations here. Again, you can solve the simultaneous equation. So simultaneous equation definitely will take you a lot of time. Okay, but that's good practice for maths. Okay, so hopefully you're able to find the answer. I'll give you the answer here. Okay, so the assignment for this Kirchhoff second law and first law is the question 3 and 4. So you need to snapshot the solution of the equations and the solution to the I1, I2, and I3, and then you will need to use the FAT simulation online to build the circuit similar to question 3 and 4 to double check your answer. Okay, I'll give you more detail in the write down. Okay, look for that in the Google Classroom.